In this module, I demonstrate a super TVM question which I call doubling the penny. It is part of the time value of money chapter, and it is sort of interesting. Suppose you can take a penny and double your penny every day for 30 days. What do you think the terminal value of this scheme will be? Or how many pennies will you have at the end of the 30 days? 30 pennies, maybe 60, 120, none of them actually. We're doubling the penny. So you go from 1 cent to 2 cents, 2 to 4, 4 to 8, 8 to the 16, 32, 64, 128, 256. That's $2.56. 512, 1024 pennies. That's 10 bucks and 24 cents, and so on and so forth. And so maybe if you hazard a guess, maybe you may say, well, that's $81, maybe, $300, $400, something like that. What if I say that the future value of this doubling the penny every day would result in $10,737,418.24. So actually you can forget about the cents and you can just say something upward of $10 million. Now that sounds sort of incredible. How is it happening? Why is it happening? Well, the reason why it's happening is because we are doubling the penny every day, which means the interest per period is actually 100%. It's not just times 2. Now you can actually come up with this exact value by using your friendly BA2 plus calculator. Here are the time value of money keys. So let's enter your interest rate as 100%. That is the key, guys. Actually, your interest rate per period is 100%. So it's not 2, it's not 20 or anything like that. Number of periods is 30. So it's 30 days. So that's 30N. Always remember, you first enter the value and then hit the corresponding function key. What was your investment? What did you start with? You started with 1 cent. So 1 cent in dollars is 0.01. But because it's an investment or a deposit, this calculator requires that you enter it as a negative value. So that's negative 0.01. There's your present value. There's no intermediate payment, so you can safely put it down as 0. You can ignore it too sometimes, but if there's a residual value from a calculation before, it will result in an error, and you don't want that. So safe thing to do is put payment equals 0. And now we want the future value of this. So to compute future value, and there you go, $10,737,418.24. Now this seems really incredible, isn't it? And like I mentioned, the reason is you found a banker who's willing to give you an interest rate of 100% on your investment, and that too not an annual interest rate, but a daily interest rate. So this happened every day for 30 days, and the key is that the interest rate per period is 100%, and this is your 1 penny. Let's see, 1 penny. And it results in something upward of $10 million. Now I've actually created an Excel spreadsheet that does the same calculation, and it's available, and this is how it sort of looks. You need to get rid of this, and so you have your 30 time periods here. You actually go from 1 to 31, so that's the number of time periods is 30, and you can specify the interest rate here, in this case a factor, so it's factor of 2, which means it doubles. And so you can see it goes from 1 cent to 2 cents to 4, 8, 16, 32, and so on and so forth. And we stopped in the previous slide at right around here, about 8,000 plus, and then it goes from there to 10, 20, 40, and 5 million, and then 10 million. There's an associated dynamic graph with it in the Excel sheet, This is plotted on a log scale, so it's actually appears to be it's a log linear growth rate. If you do not plot it on a log scale, you'll actually get something that looks like an exponential growth rate. And the problem with that kind of depiction is if the initial values are small, they really appear insignificant, and you don't actually see anything happening on the y-axis. And so it's advisable to use a log scale. And those of you who want to look at it more, you can download the Excel spreadsheet. It's in the folders. So I thought that would be something interesting. Hope you enjoyed that. This is Pank Agrawal, PhD Finance, giving you a tutorial on this topic.